All right, welcome back. We're on to 1.7, and this is actually the last section we're going to go over for chapter 1. There is a 1.8, but that's a summary of the whole chapter, so we'll have you go through that on your own. So this is the last section we're going to go over here before moving on to chapter 2. So this is going to be on division, and kind of like subtraction, we're going to change the way we think of division a little bit. You should already know some basic division. So like this example right here, 10 divided by 2 is 5. You should know that. And you probably were taught how to think of division as like splitting things up into buckets or piles or things like that. So imagine you have like 10 socks and you want to split them up into 2 different piles. How many are going to be in each pile? Well, that's going to be 5. And this way of thinking about division has always worked up until now. But moving forward into algebra, it's going to get a little bit trickier to think of it like that way. For example, dividing with negative numbers. Let's say you're doing negative 10 divided by 2. It's hard to think of that in the same way because you can't have like a negative amount of socks, right? So we're going to change the way we think of division a little bit, and that's going to help us perform different operations as we move forward. So we're going to let a and b be numbers so that b is not 0. We can't divide by 0, so b can never be 0. And if we write our division like in fraction form, kind of like this, then you know that the denominator can never be 0, because that would be divided by 0. So then the quotient, remember the quotient is the answer of a division expression. A divided by b is defined as a divided by b is the same as, here's what we're going to call this now. So instead of using division, just like we did with subtraction, where we converted it to addition and we added the negation, similar, if you remember from the last section, similar to the negation, because the negation gets you back to the identity, which is 0 for addition, the reciprocal gets you back to the identity for multiplication. So the reciprocal gets you back to 1, which is the identity for multiplication. So anyways, they're very similar, the negation and the reciprocal. One is just for addition and one is for multiplication. So just like for subtraction is the same thing as adding the negation, division is the same thing as multiplying the reciprocal. So that's what we'll be doing. We'll be converting a lot of our division problems to multiplying the reciprocal, just like we did for subtraction, where we converted our subtraction to addition, adding the negation. All right, but first we got to find out if this works or not. So if we do this, 10 divided by 2 we know is 5. So if this will actually work, then this new way has to also give us 5, right? So 10 times 1/2, remember 1/2 is the reciprocal of 2. So instead of 10 divided by 2, it's 10 times 1/2. That should also give us 5. Let's make sure that actually works, right? So let's go ahead and do this in problem 1.34. So, using the fact that 10 is equal to 5 times 2, explain why 10 divided by 2 is 5. So this is a little bit different than what I was just saying. So this is kind of just division is backwards multiplication. All right, so we know 10 divided by 2 is the same thing as 10 times 1/2. We just said that in the last slide. And so let's actually go through that real quick. I thought this first problem was going to have us do it, but it hasn't done it yet. So let's just do it over here. So 10 times 1/2. Well, if you remember how to multiply your fractions, this would be 10 times 1. So this would be 10 over 2. And if you were to simplify that, or you do long division, however you like to simplify that, you would find that this is indeed 5. So that does check out, and this does work. All right, so we know that that works now, so we can do this. So 10 divided by 2 becomes 10 times 1/2. So 10, we can split up, because 10 is the same thing as 5 times 2, right? So we can rewrite this. So this is our 10, right, times 1/2. So now we have 5 times 2 times 1/2. Again, we can use the associative property. We've been doing stuff like this a lot. We can now regroup and put this 2 and this 1/2 together, because then that makes it easy. So now we have 5 times 2 times 1/2. Well, right here, we know what this is. That's the identity right there. That's going to be 1. So now we have 5 times 1, and that's going to be 5. So division is the reverse of multiplication. So we can fill in the blank of the problem, blank times 2. So what times 2 is 10. And in order to find that, I mean, we already know that what do we have to multiply with 2 to get 10? We know that that's going to be 5. But if it wasn't that simple, if we had to do some other tricks to be able to figure out what was in this blank, we can do 10 divided by 2 in order to get back to this blank. All right, so for this next one here, let x be any non-zero number. Use a definition of division to answer the following questions. So like we did for subtraction, let's go ahead and do the same thing for this and convert these to multiplication. Go ahead, pause the video here and give this a shot and see if you can convert these to multiplication and find out what the answer is for these. All right, so this first one, we have 0 still. That's not going to change, but the division is going to change to multiplication, and this x is going to change to the reciprocal, so 1 over x. So, but what is 0 times anything? It's going to be 0. So now, again, we have x now times the reciprocal, 1 over x, and that's going to equal x over x, and that's going to equal 1. We also could have just skipped this step and just say that is the definition of reciprocal right there. That leads us back to our identity. So now we have x times, what's the reciprocal of 1 is just 1. So then that's going to be x. And what is 1 divided by x? Well, 1 times the reciprocal of x, 1 over x. 1 times anything is just whatever you had, so that's going to be 1 over x. All right, and check out this important fact over here. Let x be any number. If you're dividing into 0, so if you do 0 divided by anything, it's always going to give you 0 back. If you divide by itself, so if you do x divided by x, you're always going to get 1. So it doesn't matter if it's a million divided by a million, it's always going to be 1. If you divide by 1, you're going to get the original thing back. You should have probably learned that with fractions, of simplifying fractions. If you have like 4 over 1, that's the same thing as just saying 4. Because 4 divided by 1 is just going to give you 4. Dividing into 1, so if you do 1 divided by anything, then you're going to get that fraction back, the 1 over that x. So next one, use the definition of division to explain why this is true. Go ahead and give that a shot. This is really just the same thing. If we convert this to multiplication, we do 17 times, now what's the reciprocal of 1/5? Let's see, it's already a fraction, so we know that the reciprocal of 5 is 1/5. And we know that the reciprocal of a reciprocal gets us back to the original number, so the reciprocal of 1/5 must be 5. So that becomes 17 times 5. Dividing by a reciprocal. So if let x and y be numbers so that y is non-zero. Remember, y is in the denominator. And most of the time they were going to specify that y is non-zero to help you out there, to know that you don't need to worry about this being 0 because they tell you that it never will be. So you do x divided by 1 over y, you're going to get xy back. And this is the reason, because you flip this to multiplication and you're basically flipping this fraction. I don't know if you noticed that before now, but the reciprocal of 1 over 5 is 5 because you basically just flip this fraction over. And that does hold true in the future. We're going to do more of that, but if you have something like 2/5, if you want to find the reciprocal of that, that's going to be 5/2. But we'll talk about that more later. All right, so same sort of thing. Going to be converting these to multiplication and computing these. All right, first one here, we have -10. Let's convert to multiplication times 1/2. And let's see here. So we know that we can pull the subtraction out. We could do that in a couple steps, but we already know that this is going to give us a negative number. We have a negative times a positive. That's going to give us a negative number. So this is going to become -10 times 1/2. And we can convert this back to division if that's easier for you. So we have negative times a reciprocal is going to be the same thing as 10 divided by its reciprocal. So back to 2. And that's going to give us 10 divided by 2 is 5. Don't forget the negative sign. That's going to be negative 5. All right, so now for this one. Now we have positive 10. Now we're going to do times negative 1/2. Or, negative 1/2. We can pull that negative out here. So negative 10 times 1/2. And do the same thing that we did here. So we can convert that back to division if we want. So negative 10 divided by 2. And that's going to give us negative 5 once again. And this last one here, we have negative 10 times negative 1/2. All right, so now for this one, this is actually going to be positive. So if we pull both of these negatives to the outside, we might get something like, if we want to say that this is negative 1, we might have negative 1 times negative 1 times 10 times 1/2. And these are going to cancel out. So we're left with 10 times 1/2, which is the same thing as 10 divided by 2, which is 5. So from these, we can see that we had a negative and a positive, and we got a negative. Here we have a positive and a negative, and we got a negative. And here we have a negative and a negative, and we get a positive. So we probably knew that from multiplication already, that a negative times a negative is a positive times a negative is a negative, and a negative times a positive is a negative. So it has to be the same signs, either both positive or both negatives. That would give us a positive. Any negative mix, a negative positive mix, is going to give us a negative. Also, there's a video down here, link in the description for extra information. All right, find positive numbers a and b such that a divided by b is not equal to b divided by a. And find positive numbers a, b, and c such that a divided by b divided by c is not equal to a divided by, in parentheses, b divided by c. So this is our check that we've done with our other operators to see if the commutative property holds and the associative property holds. So let's see if they do. Let's see if we can pick two numbers so that a divided by b is not equal to b divided by a, and the same thing with the associative property. See if you can do that. All right, so for the first one, let's just try 1 and 2. So if we do 1 divided by 2, that's going to give us 1/2. But if we do 2 divided by 1, that's going to give us 2. So those are not the same thing. All right, so let's do part B. Let's use A is 8, B is 4, and C is 2. So we have, right here, we have 8 divided by 4. And that's going to give us 2 divided by 2. This is going to be 2 divided by 2, which is going to be 1. That's going to be for our first one. And now, if we do our 4 divided by 2 first, that would give us 8 divided by 2, which would be 4. So these, again, are not the same. So commutative property and associative property, division is neither commutative nor associative. Multiplication is, and addition is, subtraction is not, and division is not. So now let's see if we can go ahead and solve this problem. And remember, once again, that division is not associative and is not commutative. So we can't mix and match when you're talking about division. But multiplication is. So go ahead and give this a shot, see if you can figure out what to do here. Well, we know that we can convert division now, right? We've been doing that. So instead of having this division here, let's just convert it to multiplication, and that way we can use the commutative property. So let's go ahead and convert it. Remember, you are dividing this entire product right here. So these parentheses, they matter. So it's not just 32 divided by 10 and then call it a day. It's 32 divided by this entire product here. So when you rewrite it here with multiplication, so you can change this division to multiplication, but then it's 1 over this entire thing. So this is the reciprocal of all this. So if you have all of this stuff, the reciprocal is 1 over all that stuff. So that's how we got to right here. So it looks a little bit messy, but let's go ahead and just split it up, okay? So we have 1 over 10, 1 over 12, 1 over 14, and 1 over 16. So let's go ahead and do that. So the first part stays the same. Then we have 1/10 times 1/12 times 1/14 times 1/16. So now, look, it's all multiplication now, no more division. And multiplication is commutative. So let's go ahead and rearrange. So let's see, I see a 20 and a 1/10. I think that would probably divide pretty easily. We have a 24 and a 12. That would divide pretty easily. A 28 and a 14, a 32 and a 16. Those all seem to divide pretty easily. So let's group those together. So again, we have our 20 and our 1/10, our 24 and our 1/12, 28 and 1/14, and 32 and 1/16. So now we can convert back to division if we want to. We don't have to. We can do fraction multiplication. And then it would be 20 over 10. But that's what this is anyways, right? So the reciprocal of 1 over 10 is 10. So flip back division, and we have 20 divided by 10. Same thing as if you would have done fraction multiplication. You would have had 20 over 10. So same thing here. We have 24 divided by 12, 28 divided by 14, 32 divided by 16. So this right here is going to be 2 times 2 times 2 times 2, and that gives us 16. So much easier than multiplying all these together and then multiplying all these together and then doing some big long division to get 16. This is going to be much easier to do in your head. All right, go ahead and compute this one. It's a similar idea. So go ahead and give this a shot. All right, let's go ahead and first convert it just like we did before. So again, remember that this entire thing is the product, and so we need to find the reciprocal of that whole thing, so we get this junk here, 1 over 1/16 times 31. All right, and we can split that up into two fractions here, 1 over 16 and 1 over 31. And so we can see very easily that these two are going to go together, right? 1/16 times 1 over 1/16, and we also know that that's just the identity. That's going to be 1. And then we're left with this here, 93 times 1 over 31. You can convert that to division if you want. So that would be 93 divided by 31. I missed a parenthesis right there. And then that would give us 3. If you did 93 divided by 31, how many times does that go in? Let's see, if you try 3, then you get 3 there and 9 there. All right. So important here, cancel a common factor. Let A, B, and C be numbers such that A and C are non-zero. Then you know that AB divided by AC equals B divided by C. So basically these A's are going to cancel out, and you're going to be left with B divided by C. And you kind of see that. So if I give you an example here, so if you have, I'll just do the same example, AB, but I'll write it in fraction form, divided by AC. If you were to split this up and say A over A times B over C, which is essentially the same thing, we just kind of split it up, then you can tell really easily that this is just going to be 1, right? And then you're going to be left with B over C, or B divided by C. All right, let's do another one. Using the definition of division, explain why this is true. All right, so got a lot going on right here. So first of all, let's go ahead and convert this to multiplication. So this division here becomes multiplication. So 12 plus 18 times 1/3. And then we know that the distributive property, we can distribute this 1/3 across both of these. That becomes 12 times 1/3 and 18 times 1/3. And now if we want, we can convert that back to division again. So that's going to be 12 divided by 3 and 18 divided by 3. And that's pretty simple, right? That's going to be That's what it says right here, 12 divided by 3, 18 divided by 3. So that's all we needed to do is show that you can get to here from over here. All right, so now it's saying is 6 divided by 2 plus 1 equal to 6 divided by 2 plus 6 divided by 1. Well, let's see. We can just do that real quick. The first one would end up being 6 divided by 3, right? That's pretty simple, and that would be 2. The second one, well, if you remember order of operations, we got to do our division first. So this would be 3 plus 6, so that would be 9. So they are not equal. This one was 6 divided by 3, which was 2. So they are not equal. So this is what this is showing you, is that you cannot distribute division. Because that's what we did right here, right? 6 divided by 2, 6 divided by 1, and they were not equal. So you cannot distribute division. All right, let A, B, and C be numbers such that C is non-zero. Then A plus B divided by C equals A divided by C plus, wait, hold on a second, because this is distributing division, which I just said you can't do. So what am I missing right here? Dividing by any non-zero number. Oh, okay, I see. So this one did distribute, right? This one did distribute. 12 divided by 3, 18 divided by 3. So I was half wrong there when I said the distributive property doesn't work for division. It does work when it's on this side of the parentheses. If it's on the right side of the parentheses, it works. When it's on the left side of the parentheses, it doesn't work. And if you think about that, it's because of this. If it's on the right side, that's going to be the denominator. If it's on the left side, that's going to end up being the numerator. So it's a very different operation that you're doing. So that's why one works and the other doesn't. So remember that it can distribute if it's on the right side of the parentheses. Yeah, on the other hand, it shows that dividing into a number does not distribute over addition. So A divided by B plus C does not have to equal A divided by B plus A divided by C. So be careful with that. And again, there's a video here to give you some more information. And that is it. We have completed chapter 1. Once you complete your 1.7 exercises and then go through section 1.8 to be a summary of chapter 1. And then there's a bunch of chapter 1 problems to cover all of chapter 1. I recommend you do all of those things to make sure you have a really good grasp of chapter 1. A lot of it I know is review. You've done a lot of addition, subtraction, multiplication, division way before this course, but try practicing going over the redefinition of things like division, or the reciprocals, the negations, subtraction, the way we're doing it now, because it'll really help you out when we get to more into algebra, and will allow you to rearrange the problems a lot easier. So good job getting through chapter 1, and I'll see you for chapter 2.